Hello viewers, welcome to Bakumat. And to this lesson, we'll be looking at the Pearson's correlation coefficient or the product movement correlation coefficient. And if you're not subscribed to this channel, do subscribe and hit on the notification bell for more updates. First, let's look at the meaning of the Pearson's or product movement correlation coefficient. And when we talk about Pearson's or product movement correlation coefficient, it measures the strength and relationship between two variables. And the Pearson's correlation coefficient is represented by the letter R, just like we can see here. So the Pearson's correlation coefficient is given by the formula R is equal to n summation xy minus the summation of x multiplied by the summation of y, or divided by the square root of n summation x squared minus the square of summation x multiplied by the square root of n summation y squared minus the square of summation y. And this is the formula we are going to use in calculating for the Pearson correlation coefficient or the product movement correlation coefficient. Now that the variables means, now the main variable here are r, n, x, and y. We have explained that r is the Pearson correlation coefficient, and then the x and y are the two named variables given in the data, and then n is the number of observations. So having known what the formula is and what the variable means, we are going to look at the characteristics or the interpretation of the product movement or the Pearson correlation coefficient. That is the characteristics of R. And so when we calculate for the Pearson correlation coefficient from any given data, we should be able to explain what that value means, and the characteristics or the interpretation of the Pearson correlation coefficient is here to help us in that regard. And the first one says that the value of R lies within the inequality -1 less than or equal to R less than or equal to 1. So it means that for any R value, it should be from the range of -1 inclusive to +1 inclusive. And when we calculate for the Pearson correlation coefficient, and we get any number that exceeds -1 or it exceeds 1, then we cannot interpret it. It should be within the range of -1 inclusive and +1 inclusive. So that's the first characteristics or interpretation. And the second one says that if R is equal to 1, then we can term that Pearson correlation coefficient as a perfect positive correlation. Now in most cases, we may find it difficult, or we may not end up getting the value of R to be exactly 1, but sometimes we can get it to be closer to 1. So values like 0.9845, you can see that 0.9845 is getting closer to 1, especially with 0.9 getting closer to 1. We can see that 0.86447, you can see this value is also getting closer to 1. And so when the Pearson correlation coefficient is a value that gets closer to 1, we can also term it as a perfect positive correlation. In any ways, when it's exactly 1, we can also say it is a perfect positive correlation. Now, that is the second one. So we continue with the third interpretation, which says that if R is equal to -1, then we can term that R value as a perfect negative correlation. In other words, when R gets closer to a value that approaches -1, we can also term that value as a perfect negative correlation. So something like 4784. So R is equal to -0.8484 is getting closer to -1, and so we can term it as a perfect negative correlation. Provided the R value gets closer to -1, then we can term it as a negative, that is a perfect negative correlation. In other words, if it is also exactly -1, we can also term it as a negative, that is a perfect negative correlation. And the fourth one, if R is equal to exactly 0, then we can term it as a no correlation. There is no linear correlation between the two data sets. So that is that. So if you realize that the value also approaches 0.00002, we can see that this is approaching 0, and so we can term it as a no correlation. Or if it is exactly 0, we can also term it as a no correlation. So that is the interpretation for any value of the Pearson correlation coefficient, provided it lies within the range of -1 or +1 inclusive. Now, having understood the meaning of the Pearson correlation coefficient, we are going to try it with practical examples. So stay tuned as we work with example 1. So the examples here says that the table below shows the marks scored by 6 boys X and 6 girls Y in a test. And the table here is for X value we have 1, 3, 4, 6, 8, 9, and for Y values you have 1, 2, 4, 4, 5, 7. So I says that we should calculate the product moment correlation coefficient, knowing very well that when you say product moment correlation coefficient, is basically the same thing as the Pearson correlation coefficient. And I says we should comment on our results. Now we have our solution as such. Because the product moment correlation coefficient or the Pearson correlation coefficient is a formula work, it's guided by the formula. We first write the formula, and the formula will help us to look at how best we can solve it. So we said the product moment correlation is giving us R, which is equal to N of sigma xy minus sigma x multiplied by sigma y, all divided by the square root of n multiplied by sigma s squared. So the square root of n multiplied by sigma s squared minus that of sigma x all squared. So multiplied by the square root of n. So here will be y, sigma y squared. My sigma is not sigma, so I'll clean it and write it well so that we can see. So it's n multiplied by the sigma y, this is better, sigma y squared minus into bracket sigma y all squared. And this is the formula we'll be working with. So in the formula we can see that there are some terms that we have to find solutions to, or we have to identify them. So there is the n term, you have to find the n term, that's the value for n, and also have to find xy. When we are done finding xy, we find a summation. You have to find x and also find the summation. We have to find y and find the summation in that order. So in this case, we have to find n, we have to find xy. After getting it, we also find a summation. We also have to find x and find the summation. We have to find y and find the summation. We have to find x squared and find the summation. We have to find y squared and find the summation. So in this case, we can draw a table for it so that it makes the work so easy for us. So we continue by drawing the table for our data. And this becomes the table for our data. Now in the question, we're given the values for x and then y. And then we said that we have to find for the summation of x, y, you have to find for the summation of y squared and that of s squared. Because in order to calculate for the Pearson correlation coefficient, the summation of all these three must be known. So we complete our table in that regard. So we continue by writing here xy, we write here x squared, and then we also write here y squared. Now xy means that we are multiplying the values for x and that of y. So for 1 by 1 gives us 1, 3 by 2 gives us 6, 4 by 4 gives us 16, 6 by 6 gives us 24, 8 by 5 gives us 40, and then 9 by 7 gives us 63. That's for xy. So the next is x squared. So we are going to square the values of x. So 1 squared gives us 1, 3 squared gives us 9, 4 squared gives us 16, 6 squared gives us 36. You can see that 8 squared gives us 64, and then 9 squared gives us 81. The next is y squared. So which means we are going to square the values of y. So the first one, 1 squared gives us 1, 2 squared gives us 4, 4 squared gives us 16, 4 squared again gives us 16, 5 squared gives us 25, and then 7 squared gives us 49. So we complete our table as such. Now the formula said we find the summation of x, summation of y, summation of xy, summation of s squared, and summation of y squared. So we do that. So it means we are going to sum the values for all x, and when we sum all the values here, we are going to have 31. we also find the summation of all the y values. So we find the total of all these values. It gives us 23. We do same for xy. So for sigma xy, its summation here is 150, and that of x squared, its summation here is 207. So you have 207, and that of the summation of y squared gives us nothing but 111. So that becomes the summation of the respective terms here. So we write our formula and then do the necessary substitution, and we find for our the Pearson correlation coefficient. This is a Pearson correlation coefficient. Now the formula said that is for I. It said that R is equal to n of sigma xy minus sigma x multiplied by sigma y, all divided by the square root of, so you have n multiplied by sigma x squared minus into bracket sigma x all squared, and then it's being multiplied by the square root of n. So here we have that of sigma y squared. We can put that in bracket, it changes nothing. So you have here minus that of sigma y all squared. So once we have the formula such, we just do the necessary substitution. So here R is equal to n. So to find the value of n, we count the number of observations here. So that is 1, 2, 3, 4, 5, 6. So we have n to be equal to 6, which implies our n here is equal to 6. So for R is equal to, the first term here is n, that is 6, multiplied by, so sigma xy we saw to be 150, we substitute, minus sigma x, that was 31, and then sigma y, that was 23. So all divided by the square root of n, and then n is 6, multiplied by sigma x squared. So sigma x squared is 207, so we write that respective value, and then we have minus of sigma x all squared, that was 31, so that becomes 31 squared. So you multiplied by the square root of, at this point you can see that n is next, so you have a 6 multiplied by sigma y squared. So sigma y squared we realize to be 111, so 111 minus sigma y all squared, and that was 23, so that becomes 23 all squared. So in this regard, we continue simplifying, and R becomes, so in simplify the numerator, 6 by 150 gives us 900, and then 31 by 23 gives us 713, divided by, so at the denominator, the first square root sign when simplified gives us 1242 minus 961, and then we multiplied by the simplification of this, that gives us 6 by 111 gives us 666, and then here 23 squared gives us 529. We continue by further simplification, and our R is equal to, at the numerator, 900 minus 713 gives us 187, divided by, so when simplify the first radicand, that gives us square root of 281, multiplied by the second radicand, that gives us 137. So of which, when we finally simplify everything here, our R now becomes 0.9531, and this becomes the value of R for this question. So we've been able to calculate for the product moment correlation, or the Pearson correlation coefficient. So here we continue. So we continue by solving for the second question that says that we should comment on our results. So now we have the R value to be 0.953. What does it mean? What conclusion can we draw from this R value? So we go back to the interpretation of the Pearson correlation coefficient, or the product moment correlation coefficient, and that will help us to draw conclusion for the R value to be 0.9531. So from the beginning of our lesson, we said that if R is equal to 1, then it's a perfect positive correlation. In other words, if R approaches 1, then it's a perfect positive correlation. If R is equal to -1, or if the value of R approaches -1, we can term it as a perfect negative correlation. In any case, if R is equal to 0 or it approaches 0, then we can term it as a no correlation. So in this case, from the question we just solved, we said R is equal to 0.9531. So we can see that this is a positive answer, and this answer 0.9531 is approaching positive 1. So that is approaching this. So therefore we can see that our R value here is a perfect positive correlation. So we go back to our solution and write that conclusion. So here we have. So from what we just realized, we can say that since R, which is equal to 0.9531, approaches 1, it implies there is a perfect positive correlation between the six boys X and 6 girls Y. So this is our interpretation for the R value to be equal to 0.9531. So we end to this video here, and I believe you really understand what it means for us to call an R value as a product moment correlation, or the Pearson correlation coefficient. So we end to this video here. Thanks for watching. Kindly like, comment, subscribe, and share. Remember that this is Bakuma, the thinking beyond infinity. See you in our next video. It's bye bye for now.